Great, welcome back, guys. So now for the next talk, we have Damien Segi. He is CTO of Exacat, and Exacat, hold on, where is it? Oh yeah. So Exacat is a company that specializes in PHP code quality for code quality solutions for the industry. And he also leads the development of the Exacat static analysis engine. It's something that automatically reviews your code for version compatibility, security, and clear code. So today he'll be talking about teaching PHP new tricks of machine learning. I'll let Damien take the stage. Please give him a warm welcome.
So welcome, everyone. I think after 3 days for the most courageous of you of learning PHP, you are going to be very interested to have the only session that will tell you that PHP can do on top of what it's doing instead of you do, which is we're going to teach PHP to do things and not code on our own, but let PHP understand the problem and solve it for us. How good is that? Awesome. Yeah, wow. And the rest over there is sleeping. Be aware that I will be asking questions during the talk, so be ready to answer them. You okay? Yeah, I'm threatening you. Anyway, so we're going to see how to teach new tricks to PHP without relying on Dave A, who's already read his master, but we're going just to give it the information and PHP will solve the problem on its own. And that will also be applied to a very specific problem that we have in PHP as in any other language, which is code in commons. So we're going to solve the problem of code in commons. You know, like everyone is coding, and then at some point you decide that you don't want this line of code or you want to debug it. Well, then you're going to leave it in a comment, and then it's going to get committed, go to production, and raise some bugs. Well, not exactly, but we're going to try to chase them down and remove them from a large code base, which is PHPMyAdmin. So, as mentioned, I'm CTO at Exacat. We're not doing machine learning on a regular basis, but we're introducing that to refine the results. Anytime we have static analysis, at some point, the machine is not able to go further when we look for objective issues in the code, and we use machine learning to reduce the number of false positives in our research. So what is machine learning? And I will start with the first question. Who among you is a parent? Kids. 1 kid, 2, 3. Don't be shy, it's okay. I have them. I have some of them too, right? So very little. Not the same kids, I guess. So machine learning, 2 words. Machine is for computer. That will be basically PHP here. So we're going to have PHP learn something. Instead of us learning what is Laravel or what is web security, we're just going to end the task to PHP. That's exactly the way it works. And if you think about it, the way we work with PHP is very imperative. It's a dog. Oh, okay, it's an elephant. But it's a dog. We say sit, roll. And sit again, fetch. We give orders. And PHP is just there to listen to the orders, take the command, do it. If it's stupid, PHP will do it anyway. If it's smart, well, it will also do it, but then it's a smart command, right? So now we're going to change that and be more in the idea of, in the approach of teaching a kid, okay? We're going to show him what to do, and it's going to repeat that until we, as the teacher, are going to be satisfied. It's more like a shofu kind of stuff of learning. So we'll have 2 different phases. The first one will be the training, and the second one will be the application. So the usage in the real world without our supervision. What can we do with machine learning? I'm sure you have examples. AlphaGo, the recent contest of playing Go that was mastered, and like the best player of Go in the world has been defeated like 4-1, something like that, earlier in the year. That was made only on machine learning with exactly the same principle, although a little bit modest, than the one I'm going to show you. What can we do otherwise? OCR, optical character recognition. That's a very difficult task, very complex, and it means lots of training. And then when you have it running, you want it to be fast and recognize the character quickly. So that's a good one. Medical diagnostic. So once you realize that your doctor is going to be replaced by a robot, that's machine learning. Probably not with PHP, but anyway. If you've seen also robot walking, that's a lot of machine learning. Just like kids, you know, they learn, they see, and then at some point it works. But this is nice, although it's not going to be very applicable. I'm not going to show you how to beat, you know, World Master of Go using PHP. But what can we do in terms of application? What is very interesting in this supervised learning system is that we have a first phase where, as developer, we're going to work on the content, make sure the machine understands and develop the right model, learns correctly, and when it's done, we're going to push this model, which is a very tiny file of configuration, in production, where it will be applied to web, okay? And in terms of web, it's going to be able to answer pretty fast and sometimes saving us lots of complex calculation through the database, through just pure calculations. So that's where it's handy for PHP. You already used spam, you know, spam filters, not in PHP, but that's the same idea. Or that would be recommendation systems. Think about it like e-commerce. You have people who have the selected 5, 6 items, and you want from those 5 or 6 items to recommend a 7th, so that they will, you know, add that to their own code. That's machine learning at its best. And we're going to do that in a very specific problem that's plaguing us, as I said, coding comments. So what is the difficulty of, well, the situation with coding comments is that, as I said, everyone will add some comments, maybe hide some code for debugging purpose, for reserve for future use, things like that, and it will just forget it. Now, if you have a small project, like it's the trend nowadays, then probably you'll be able to review 5, 20, 30 files and just clean all those comments. Now, if you're called PHPMyAdmin and you have like 800 files and 1 million lines of code, and historical code from 1 year, for 10 years, you don't want to do that. Well, we're going to try to do that. There's about 14,000 comments. How many of us today? We're like 60 in the room. How long do you think it would take for us to read all those comments and clean them? Yeah, I'm waiting for an answer, that's right. Yeah, at least an hour, right? Maybe we can do that faster than that. So this is a classic problem. It's very good for machine learning because it's a complex problem, okay? Extracting the eigenvector of an imaginary matrix, that's going to be a piece of cake for PHP, right? Everyone knows that. On the other hand, reading comments and understanding if the code is partial or not, if it's PHP code or Python code or maybe broken code, that's very difficult. We usually require our own intelligence to do that and to be able to sort the comments and that. So that's a complex problem which has a large number of good reasons to conclude. So machine learning is going to be very good for that. We also have a lot of expertise available. I'm sure you're all expert in comments. This is the moment you say yes. You've all been writing comments, right? Yes, so you know you can put lots of things in it, drawings, code, insults. Sadly enough, it's too often. So here is the synopsis for today. As you can see, there are 2 branches. The first one is going to be the training. We start with data, history data. We start with our own experience. We start with this data. We do the training, and then we'll end up at the end of the first phase with the model. And the model can be stored. Okay, so we stop at that point. Second part, we'll take PHPMyAdmin, all its comments, push them through in the model, and have our actual results. Simple enough? Good. So we start with that. The first element we need is an engine. Okay, we need something that is inside PHP that will actually process the incoming data and produce the model, and that's the FAN extension. If I remember correctly, Fast Artificial Neural Network, and that has been a code that has been around. That's a library that has been around for at least 2 decades. You're going to see that later. That shows there's a lot of history, behavior that are funny to find. But it's also been available to PHP since PHP 4, I think, and it's working on PHP 7. Thanks to Jakub Zelenka, who's been very kind to push that very fast, although apparently there's not too many people using the extension, but it works. So that's a side compilation. Download it with Pickle, install it, and it runs. Very simple. And it's going to bring us the neural networks to PHP. Who's been using neural networks? 1, 2, only 2? Well, 3 counting me, I guess. Okay, so let me try again. Who's been using his brain? Okay, good. Half of them have no brain. So neural network is it's a system to implement the learning that's based on the actual biology. Okay, it's based on the number of neurons we have. You can count, especially for the youngest of us, about 100 billion neurons. Although no one has ever really counted them, but that's basically what you're made of. A good 20% of them are used for just transmitting information, okay? Someone hurts you on your foot, there are a number of neurons that bring everything to your brain, so you can count like 80 billion neurons that are available to collect everything, your history, your memories, your reactions, and handling all your organ internals function. So that's one part. How does that work? There is the first this tree-like structure, which are called the dendrites, which are collecting the information. Every single little point is a connection to another neuron or to a sensor, like for touching, for the eyes, or things like that. It will get the input, the electrical input, that will be sent to the center. The arch of the neuron will actually collect all those information together, and at some point it will decide that it has to trigger something. And at that point, that's the threshold, it will release electricity that will go down the axon, much further, up to like 2 meter high, and send that to something else. So your brain decides something, and you raise your foot. That's the way it works. Now, you also have to consider that, as I said, 15,000 dendrites for one neuron. If you think about it, PHP, that's a 15,000 condition if-then. Yeah, and now again, to compare that with PHP-MyAdmin, there are 7,000 conditions in PHP-MyAdmin. So one neuron could fit actually 2 PHP-MyAdmin. And I made a slight calculation, but I think one neuron would probably have as many conditions that on my whole career I've ever written. 15,000, you can imagine how many that represents? That's huge. And you have 80 billions of them that are interconnected. Hopefully we're going to make that fit with PHP. Anyway, we start with that. Usually neural networks in their computer counterparts works with 3 layers. There is one layer which is the input, and we're going to work on that in a moment. There is in between all those layers that are just for internal calculation, for which we will not exactly know what happens, but the training will set everything inside. We just decide how many layers we want, so the blue lines, and how many neurons that will be there. Okay? And finally, we have one output. Here, we will just decide if it's a comment, if the comment is code or not, so just true or false. That could be a spatial position. Okay? That could be X, Y, Z, and you have coordinates. So you can have actually complex output, categorization, things like that. Okay? I've been talking a lot, so let's take a look at actual code. Given fun, given the structure of a neural network, here is the first part of your code, right? You can see there is fun, create standards. This is really funny because fun extension has a really long names, so that's always horrible. But we give it all the information I mentioned, number of layers, number of input neurons, number of output, and the hidden ones. We just give that, and then fun is going to take care of the rest. The other things that I just mentioned, it's from the doc, and that's going to make your code full, but this is the threshold application, the threshold function. As I mentioned, the heart of the neuron will filter part of the incoming electrical input, and this is what is most used, sigmoid symmetric. I won't delve into that. Now we have the engine, now we have our very little brain. We need our first data, right? So let's start with that. We're going to start from PHP. That's going to be our source, and that's usually how it happens, right? We're not going to get the comments out of the blue from PHPMyAdmin. They have no idea what's in there, and that we're going to do this analysis tonight. So we start from the code. The first thing, we do the extraction, which is looking into this unstructured data and extracting the information that is interesting for us. Anyone knows how to remove or extract data, comments from PHP code? You've raised your hand too many times. Okay, basically we use the tokenizer to turn the code into tokens. There are 3 tokens that hold comments: single line, multi-line, and PHP docs. Okay? So that's the part of the process that's completely objective. Okay, we're going to give the code to PHP. PHP breaks down in token. We filter the one that are comments, the rest out. We don't need that, and we keep them. Okay, simple enough. Second part, we have this raw data, but we can refine that. We're not going to train our neural network on everything because there are a number of things we already know for sure are not going to be useful, right? We mentioned comments, single line, multi-line, and PHP docs. We can drop PHP docs. They may contain code, but that's probably not going to be code that has been, shoved aside to let the rest of the implementation run. So this is, again, from the raw data, you remove everything you can that is as easy as possible to remove. Second part, we also do a human review. What is human review? It means that maybe on single lines or multiple lines comments, we can understand and look at that and understand immediately that this is not going to be code. We're going to see a few examples, but that's an important thing. We don't just extract raw data to give that to the system, but we just remove the ones that are completely useless. And we end up with data that's ready for fun. Now, the thing is, we have a number of comments. What do we need to do as experts? We have to tag them as code or not. How is that? How difficult is that? Difficult? Not difficult? Okay, let's give it a try. Here is a little list of things we're going to do the training on. What do you think of the second comment? Can someone tell me if they think it's code or it's not code? Second comment? No. Third? Some code is inside. I don't want that. I want yes or no. So some code, maybe, tomorrow, those are answers I don't want to hear. No, that's good. Actually, it's easy because the red thing means that I have already did the sorting for you, right? Yeah, you're learning. That's great. I see more people than that have brain. At the bottom, on the other hand, we have things that are obviously code, right? Even if it's partial, then it's code, right? In between, let's do a survey. The thing that is, as with the gradient, the first one, A and B and multidimensional. Who thinks this is valid PHP code? 1, 2, 3. Okay, it's good. I just want yes or no, but you can decide not to vote, right? Now, who decided this is not PHP code? And we have more people, right? That's more like 20. Okay, at that point, this is the moment where your expertise is needed. At that point, those 3 of them do not have an explicit answer. We may decide differently depending on our sensibility, depending on how we know the code. Maybe this is actually something that could be found, mixing two different kind of logical operators is difficult, but that happens, right? But this is the moment where we need the expertise, okay? Everything that's objective, we can decide easily and agree on, probably is not the most interesting. This is making the difference between different experts and their opinions. Meaning that you can do this expertise on your own, one, or maybe have other people, but just know that there's not always a good answer. Now, we're going to have another part. We have that, right? We have those comments. But we need to input numbers into FAN because it's not going to read English or PHP for that matter. I would like you to think a little bit and give me things that you would like to look for in those comments that will be characteristics of a code or not. So let's say, for example, we take a look at that. Variables. This is very typical of PHP. So if we find a structure which has $ and a few letters right after, this is something that's typical of PHP code. Note that this is not necessarily always code, right? The second one, as was mentioned by, I don't remember who, this is some code is inside, okay? But this is something that's usually characteristic. Can you give me other ideas of things that could be characteristic and help us decide if it's code or not?
You can either shout out your answers or head to the mics at the back.
Semicolon at the end. Yeah, that's another one. There are 1, 2, 3 here. That's a good one. Other ideas? Keywords. Like? If equal, okay, so PHP keywords, that may be the classic conditions, while, do while, things like that. Or that could be PHP typical application functions, die, DL, var dump, things like that. What else? Highlight.
Yes. Not there, but like in general.
What do you mean highlight? Syntax highlighting? No, we're talking about plain text, not IDE stuff. So, no. An highlight would be the same than preceding, that's keywords. You make a list of keywords, and those are the ones that will be helpful in characteristics. Other ideas? Bracket and code brace, yeah, that's kind of useful also. So, first raise your hand because otherwise I don't know who to look at. Operators, yeah, that would go in the same category as keywords, so that's a good variation. Quote strings, quotes maybe, quotes, is that what you're mentioning?
Quotations? Yeah, I think the quotation marks.
The quotation marks. Well, all of them are used, and I think they're also used in language. That could help. Another one, finally, by there, yeah. Patterns? Can you be more precise like that? Could you be more precise? Because pattern is kind of general, that's what we're looking for. Yeah, but that would look like you want to make a regular expression for like an assignation, something like dollar variable equal, and yeah, a little more complex, I guess. That could work. One thing that could be useful. Thank you, Sherry. The list of characteristics we're going to use, well, we're going to stop at some point and have to go on. The list of characteristics we're going to use is short here because I want to fit on the slide, but it's completely mine, okay? And that's a first try. So operators, that was mentioned. There is one, that's not my choice, but that works too. Semicolon, I just count them. I don't care if they are inside the string or if they're outside or whatever. I just count them because it's not such a useful punctuation sign in English. Number of equal, the dollar, but I just count dollar. I do not even take care of variables, just dollars. And the size, the sheer size of the comments, Most often, people do not like to write long comments to just show aside a piece of code. So if it's long, maybe it's a full function or something like that. This list is completely arbitrary at that point, right? So keep in mind all your ideas. You'll have time to make them better, to make that better. What's important here is from the text we have extracted, we can now make very simple searches and convert the comments into numbers. And that's exactly what fan needs. So we're not going to spend too much time here. This is the ugly file format that fan requires. So basically, from the comments, we need to turn everything, all the characteristics into numbers. So there is a first line of header, very C style, the number of training set, the number of incoming data, which are the number of columns, the number of outgoing data, which means that we have sets 45 set of 2 lines. Each line is a set of 5 number and a set of 1 number, and that's repeated. You have an example on the side. At that point, and before we start actually do the training, I would like just to share a feeling I have, because you can imagine that we're trying to look for code in comments, okay? So something that's kind of structured, we can understand. What did we do? We got some text, we counted characters to turn that into numbers. This is the input for fan. Fan reads those numbers. If that was a count of carrots, if that was a number of kilometers that was, traveled by a snail, I don't know, I don't care. But fan is still going to output something. It means that the part of the expertise, the part that we turn the code into some numbers is really important. This is the one that's going to give the meaning. In between, the machine is completely blind. I have absolutely no idea what we're doing. It just depends on us to apply that to some reality. Kind of black magic, I think. But anyway, it works. To complete the first piece of script, here is the training. Remember, I introduced 1, 2 functions. This is the third one, right? We have to provide the initial resource. We have to provide the data, and we have to provide the desired error. That's cool, right? Who have ever done that, Here, some data, and I want no error. Do some work. That's nice. So we start with a desired error of 0.1, what's like 1,000th? Interesting. What do we want to do? Thing is, if we start with a very a very high error, fan is not going to train hard. It's just going to do whatever it wants until the number of errors is within the margin we have asked. So if we make the error way too high, it's going to train very fast. Okay? We give it a very light load, it's going to train something and makes lots of errors. But that's what we asked. So what can we do? Of course, we can lower the error and raise the challenge. And probably that fan is going to work a little more, make it a little more complex, but remove a number of errors. And then at some point we can say, hey, we're clever, we want him to train exactly on the data we have, and fan is probably going to succeed. But suddenly it's going to be really weird and probably overfitted for our training. Remember, we are training it on a number of comments, and it will meet something else. So there is a level of error that you have to choose, and it needs some experience to do that. As for me, I just started with the documentation values, and it worked very well, so that was nice. Now, training, real case. Here is the actual values that I worked on. So to train for PHPMyAdmin's analysis, 47 cases, not too many, 5 characteristic incoming, and our configuration of 3 hidden neurons, 5 input, 1 output, 6 seconds of training. We can do that, right? We can do that, that's nice. So we're done, we get a file which is also a few kilobytes. Don't try to read it, it's unreadable. But we can reuse that and now put that on real data. The application of the code of the model is just as simple as the code previously used, right? We again create another resource. We create the vector, so even from the real case, we need to extract the comments and build the same characteristic than the one we use for training, of course. Otherwise, the system is not going to recognize anything. Then we just call run fan, and we get the results in an array. How cool is that? Except for the long names of function for fan, no difficulty there, right? And to be true, we really want to have results that are above 0.8. Anyone have an idea what that means, 0.8? Obviously, everyone has an idea. I have no idea what's that. It could be a score, it could be carrots, again. I have no idea. We have inputted a number of counts, counting number of dollars, we have counted characters, and we have counted operators, and we get a number which is a composition of all of that. I have no idea what that means. So is this a percentage? Is it something else? And beside that, we said, you train between 0 and 1, true or false. We get results ranging from -15 to 1. I don't know how he found that. Apparently, closer to 1 is good, and lower to 0 is bad. And so we decide to have a threshold. Over the 14,000 comments that are available in PHPMyAdmin, here is the repartition of them. So as I said, it starts with -15, and it goes up to 1. And when we get close to the end, this is the way the repartition goes, you see. From 60 to 70 is very steep, then suddenly there is a little flat, and again it goes as a stair. Okay? Meaning that for 80, we could actually be missing a quite large number of results. Again, this is completely random. It's up to you to take a look at the way it's distributed and to decide where to exactly put the 0.8. That could be a little lower, that could be a little higher. Anyway, the results on PHPMyAdmin are those ones. 14,000 comments. Script execution to analyze all those 14,000 comments is 68 milliseconds. We said, how many? We are like 60 of us, and we work an hour, we have no results. I cannot even remove my finger from my keyboard, and it's done. And we have about 14% of issues. Now, first count, who thinks it's a lot? Too much? Do you think that's too much? Who thinks that's too much? We're finding too many comments. Okay? Who thinks that's about the number of comments they would expect? Who think that should be lower than that? Okay, so 3 people more, and the rest is sleeping. Here are the results. Oh, here are some of the results. So, can you imagine that? 27 minutes of work, and we actually spot lots of code, okay? Among the 2,000 we have those, and we also find those. Oops, that was too fast. We also find those. Now, as I said, I introduced you with 5 functions from FAN. That was very simple code. Where's the bug? How come do I find errors here? Do you think there's a bug in my code? I'm looking at you guys. No, there's no bug. Welcome to a world where there is no more bugs. This is the first script you see that has no bugs. Only false positives. So false positives are things that the machine will find, but we do not agree with. Right? So there is everything. Everything that is positive is something that FAN will find. Everything that is true is something that we'll agree with. And we have everything. The true positive are the one we want. FAN found it, and we agree with it. That's the best. The other one you also like is the false negative. Okay? FAN do not find it, and we agree also that it's something that should not be found. What we don't want is the false positive, which are the most often talked about case, and the true negatives which no one wants to hear about because FAN didn't find it, and we don't want to do the work of FAN to check what he hasn't found. So usually people don't find that. And I think I have to be done. So let's skip that. In terms of results, if we analyze them and review the 2,000 of them, about 50% of them were very simple and repetitive strings. Remember when I told you initially that everything that's obvious that should not be tested here or trained on, like a Vim configuration line, that's basically on every single file because Mark is using Vim to produce PHPMyAdmin. Well, we can spot that and remove that. There's also a large number of paper configurations for some PDF printer in that we could remove also very easily. That will actually reduce the training and the false positive to 800. at least. And then we can start again, do our own work and review them. The total time to do that from beginning to now would be 27 minutes, excluding the compilation of fan. I will leave that to you. But it means also that, you see, doing something that will reduce the amount of work from 14,000 comments to read to 800 to check with a really interesting level of true positive is 30 minutes. So that's interesting. That could be applied to many situations. You can give it a little try, half an hour, get some data, train them, get some result. Is it interesting enough? Is it like 50% is already removed and we can just reduce the work we do? Okay, that's interesting. Or you try it, it doesn't yield any results, or it's really bad level of true or false positive. Yeah, just ditch that and finish by hand. So to leave some room for the next glorious speaker, I will make you read online all the lines that is how to make what we've seen better. The most important, and this is why machine learning is often associated to big data, is that if you want that better, we started with 47 comments, more data, more training. The more you have, the better the training will be and the more precise it will be. So in any case, that's your first optimization. Get more data, get other applications, review them, check the results and put them back, train again. Training was 5 seconds, so iteration should be really fast. Actually, this is the evolution of the time of training, depending on the amount of neurons and layers you have inside. So even if you want to make it really complex, it's still very fast. On the other hand, results are always very, very fast to come, but they may vary a lot. Actually, again, I was I was clever to read the doc, but I was lucky. 1 layer, 3 neurons. If you see, this is almost the best. I could look a little further, and maybe with 5 neurons, that would be even better. But still one layer. Otherwise, the result can vary from actually what we found to almost everything. The whole training here and testing would be another, how many that? Like there's 50 configuration, 5 seconds by 50, it's 10 minutes, and you have this graph. 10 minutes and you have this graph. So you can pick exactly the good configuration and make it run for you. I'll finish with that. If you want other tools, Fan is nice because it's in PHP, so you can use it on a production server, but it's really you yourself with the data and no ID to do anything. So that's nice, but there are other tools that are more interesting and that will bring you further into the world of machine learning. Give it a try. And that will be it. There, thank you.
Thank you, Damien. Does anyone have any questions for Damien?
This is your time to fight back and ask me questions after the number of them asked.
Yeah. Do you need the mic? Or? Okay.
Yes. Yeah, of course. Yeah, of course. The retroaction is what I've shown very briefly on the feedback on the making better section. So you do a first run, you realize that you have missed a number of false positive, you get them, put them back in training, maybe at the same time get some also true positive, put them back in training, go from 47 to 100 lines, train, and try it again. At some point you'll probably get the feeling that you will reach a flat in your progression, then you can stop. Okay, but yes, retroaction, that's the easy one. There are also learning techniques which include directly the retroaction, which is not presented here. Yes? Inside the static analysis, at some point, as I said, analyzing the codes and trying to guess if there is a problem is good, and I try to do it as objective as possible. But at some point, usually, I have to do some wild guess, and I try to push that to machine learning. So once I've done whatever I can do, and I can argument about it, then I stop, and the rest of the results, then I do it by experience. I go myself in the code and reach the conclusion and train a little model on that. So that's my main case. The other one I mentioned is either filtering out data, and that could be even for identification. I don't tell you to run your identification, your login system on that, but if you have something that fast and that prevents you to go to the database to detect something that's fraudulently tried to connect, then you're saving a lot of resource, okay? If it passed this first filter, which has some error level but is okay, then you can go to the database and save the database maybe 80% of the hits. That's interesting. That's exactly the way I use it. Try to filter out some noise, things that you cannot remove and for which you have difficulty to find the objective filters. Use some training like that and finish by something that's really powerful. For ETA. So when I have scripts that runs, for example, I never know exactly how long it's going to take for one analysis to run, okay? And I have 200 of them, and the structure of the code may have different impact of my code. So I also try to use that for that. So anytime I run the analysis, I log the time, and I use the time and a few characteristics from the code to train the data and have an estimation. So instead of just counting the amount and the number of tasks, that's usually more precise. And no one really cares if it's too erroneous or not.
So basically, the fan can be used for machine learning in case of we want to analyze the customer behavior. So we have a lot of data.
Yes.
And we can go through this.
Yeah, you're going to have a lot of fun with that. You have a big database with lots of profiles and information and characteristics, and you want to link those characteristics with the fact they buy, or they go to this section, or they buy this product. Yeah. Help yourself. That's going to be fun. Yeah?
How do you reduce the subjectivity of choosing the characteristic?
With fan, try error and try. Try and error, whatever. You give it a try. If it's better, you keep it. If it's worse, you just remove it. Okay, at that point, we want to bypass human thinking to be able either to explore things that we do not think about or to remove options that are not interesting. So don't break a sweat too much. Think about it, but don't overthink it. Just, okay, here is a few options. I give it a try. If I remove one, as I said, it's very fast to have a feedback. So I remove one. Is it better? Yes. Okay, I just remove it. And I try to put some others. Retroaction. Now what happens also is, this is very rudimentary. This is really good for a session like that, so you understand the different phases of the machine learning. There are also tools, IDs that will do this work for you and give you some certainty or some efficiency for every characteristics. This is not the case here. Yeah, yeah.
How do you about the true negative?
The other ones, yeah. Now, between you and me, but I don't want to have that public, I didn't check them. So, as you said there, the 40% that was detected by FAN, that's the one I reviewed because that's the true positive or the true negative. The other one, I just didn't check them because this is training at that point, so I don't want to review the 14,000 to know how good it is. I can also open the rest and make a quick check, just don't read all of them, but try to detect if there are things that have been missed that are obvious. Otherwise, at that point, yeah, you have either to trust your system at training level or review it. But yeah, you should be testing the two of them until you're satisfied with the level of certainty.
Any other questions?
Good,
No?
thank you.
Well, thank you, Damien. Now we're coming to a close of